All right, everyone. In this video, we're going to talk about our oxidizing reagents, PCC versus chromic acid. All right, so the first thing to recognize is that when we're oxidizing an alcohol, what we're essentially doing is taking that carbon bonded to the alcohol, and we're going to turn it into a C-double bond O compound. Now, the C-double bond O compound that we create, whether it's an aldehyde or a ketone or a carboxylic acid, that's going to be dependent upon the combination of the classification of the alcohol and then which oxidizing reagent we're using, whether we're using a mild oxidizing reagent like PCC or a strong oxidizing agent like chromic acid. Let's start with the weak oxidizing agents. Or a mild oxidizing agent is PCC. With PCC, that's going to oxidize a primary alcohol to an aldehyde and would oxidize a secondary alcohol to a ketone. So looking at this example here, we have a primary alcohol, and we're noticing that with PCC, that carbon is oxidizing to the carbonyl carbon of an aldehyde functional group. Primaries with PCC oxidize to an aldehyde. The secondary alcohol on the right side of your screen there, that's going to oxidize to the carbonyl of a ketone. Now, notice why the primary and secondary are able to actually oxidize is that there's a hydrogen bonded to the carbon connected to the alcohol. There has to be at least one hydrogen on that carbon bonded to the alcohol for oxidation to occur. And that's precisely why the tertiary alcohol is not undergoing oxidation. There is no hydrogen at that carbon, and therefore it cannot oxidize. So we'll say that tertiary alcohols will not oxidize, nor will phenolic OHs oxidize. And that's kind of for the same reason. There's no hydrogen bonded to that carbon. Therefore, no oxidation can occur with phenolic OHs or tertiary alcohols. But PCC certainly can oxidize primary and secondary alcohols, where the primary becomes an aldehyde and the secondary becomes a ketone. And just for the records, PCC stands for pyridinium chlorochromate, PCC. Now let's look at our strong oxidizing agent, chromic acid. Chromic acid is written as H2CrO4. Chromic acid, that's a strong oxidizing agent. Please recognize that this could be prepared in situ, meaning in solution, wherein we could combine Na2Cr2O7 with aqueous acid, or we could combine CrO3 with aqueous acid. So you could see chromic acid straight up written as H2CrO4, or in either of those two preparations as well. Just important to recognize that those are both preparations of chromic acid. Now, chromic acid is a strong oxidizer. PCC was a mild oxidizing agent. With chromic acid, we're going to oxidize that primary alcohol to a carboxylic acid. With the primary, H2CrO4 generates a carboxylic acid, and a secondary with chromic acid would oxidize to a ketone. Again, for your purposes, we're going to see that there is no oxidation of a tertiary alcohol, given that there's no hydrogen on the carbon bonded to the alcohol, nor would phenol oxidize as well. So no oxidation of tertiaries and no oxidation of phenol with chromic acid. Now, you're probably noticing already that the main difference in how these oxidizing agents function is with respect to how they oxidize a primary alcohol. PCC oxidizes the primary to an aldehyde, whereas chromic acid oxidizes that primary alcohol to a carboxylic acid. Now, you don't need to know the mechanisms for how these transformations take place, but what I would have you know is this. When we're oxidizing that primary alcohol to the carboxylic acid with chromic acid, there's going to be this initial oxidation from the primary alcohol to the aldehyde, which is in this case an intermediate in that oxidation process. The aldehyde is then going to undergo a hydration. Consider that we're an aqueous acid here. It will form a hydrate. Imagine protonating the carbonyl, water then attacks and bonds. We form a hydrate. And then there's a second oxidation that takes place where we oxidize the hydrate to the carboxylic acid. So what I would have you know is conceptually, there's an oxidation, then there's a hydration of the aldehyde intermediate, and then another oxidation. So an oxidation, a hydration, and then another oxidation takes place. You don't need to know the mechanism, but I would have you know that conceptually there's an oxidation, a hydration, and then another oxidation. Now, why it's also important to look at this visual is because the aldehyde is itself an intermediate in that oxidation of the primary to form the carboxylic acid. You could straight up start with an aldehyde, hit it with chromic acid, and that would then oxidize to the carboxylic acid. Right? Now, the other detail is if there's multiple alcohols in the structure, whenever you see an oxidizing reagent paired with it, you're going to oxidize any and all alcohols that can be oxidized. And then if an alcohol cannot be oxidized, like the tertiary, you would just leave that unchanged. Okay? Just to recap what we've said here is PCC is a mild oxidizing agent that would take a primary alcohol, turn it into an aldehyde. Secondaries would oxidize to ketones. With chromic acid, there are a couple different preparations in terms of how you can see that written, but it would take a primary to a carboxylic acid. That's a more extensive oxidation of the primary alcohol. And secondaries would become ketones, but in each case of mild versus strong, there'll be no oxidation of tertiary alcohols, nor any oxidation of phenolic OH groups.